Hello friends, in this video we are going to study about the converse of midpoint theorem and the examples based on the midpoint theorem and the converse of midpoint theorem. In the previous video we studied that or we learned about the midpoint theorem. Midpoint theorem is the statement is the segment joining the midpoints of any two sides of a triangle is parallel to third side and is half of it. Now the converse of this theorem is the converse of midpoint theorem. The statement is if a line drawn through the midpoint of one side of a triangle and parallel to the other side, then it bisects the third side. Here we draw the figure ABC. Point D is the midpoint of side AB, and the line passing through this midpoint is parallel to side BC, and we have to prove that this line bisect the third side. It means that this point E divide the segment AC in two equal parts. That is, we have to prove that AE equals to EC. First, we have to write the given to prove construction and then proof. Here in triangle ABC, point D is the midpoint of side AB. Then this line L passing through the point D is parallel to the side BC. Line L passing through point D is parallel to side BC, and we have to prove that which intersect side AC at point E हे पण आपल्याला याच्यामध्येच लिहावं लागेल. Which intersect side AC in point E. Then from this information we have to prove that this line divide the side AC. It means that AE equals to EC. AE equals to EC. Here we construct this construction. Here we draw the line or segment parallel to the side AB through the point C, which intersect the line L at point F. So draw a segment or a line through the point C, which is parallel to side AB and intersects line L at point F. It means that here CF parallel the CAB. Now here we add the proof. Here in this quadrilateral DBCF, here this DB parallel CF because construction, because here we draw this CF parallel to side AB, that's why DB parallel FC or BD parallel CF, and side DF or sec DF parallel sec BC. It is given because this line L is parallel to side BC, therefore DE parallel BC. It means that this quadrilateral is a parallelogram because both the pairs of opposite sides are parallel to each other, and as this is a parallelogram, then this DB equals to CF, BD equals to CF. These are the opposite sides of parallelogram, but it is given that this BD equals to AD, and therefore AD equals to CF. Now in these two triangles, the side AD congruent side CF, आताच आपण ते प्रूव्ह केलेलं आहे, त्याला नंबर दिला तर फ्रॉम 1 लिहिता येईल. Then this angle DAE congruent angle FCE, because these are the alternate angles formed on these two parallel lines, so these are the alternate angles. And these triangles are congruent because these are vertically opposite angle, and therefore these two triangles are congruent by SAA test. Now, as these two triangles are congruent, then their corresponding sides are also congruent. Therefore, seg AE congruent seg EC. These are the corresponding sides of congruent triangles. And that is AE equals to EC. तेच आपल्याला इथं प्रूव्ह करायचं आहे. त्यासाठी अगोदर आपल्याला हा क्वाड्रिलॅटरल पॅरलोग्राम आहे हे शो करावं लागेल आणि नंतर त्याच्यावरून आपल्याला हे दोन ट्रायंगल कॉन्ग्रुएंट आहेत हे दाखवता येईल. पहा, इन क्वाड्रिलॅटरल DBCF seg BD parallel seg CF, it is construction. Then seg DF parallel seg BC, it is given. किंवा लिहूया line L parallel seg BC दिलेलं आहे आपल्याला हे. And therefore quadrilateral DBCF is a parallelogram. And therefore seg BD congruent seg CF. These are the opposite sides of parallelogram. Now, but seg BD congruent seg AD, it is given because D is the midpoint of seg AB, and therefore seg AD congruent seg CF. याला देऊया number 1. Now in triangle AED and triangle CEF, in these two triangles seg AD congruent seg CF from 1. Then angle DAE congruent angle FCE. See in figure मध्ये पहा angle कुठे आहेत ते. These are the alternate angles. Then angle AED congruent angle CEF. These are the vertically opposite angles, and therefore triangle AED congruent triangle CEF by SAA test. आता या SAA टेस्ट बाबतीत आपण ट्रायंगल्स या चॅप्टर मध्ये पण पाहिलं होतं, अभ्यासलं होतं. इथं SAA टेस्ट आपण अभ्यासलेली नाही, तर SAS त्यानंतर ASA ही टेस्ट अभ्यासलेली आहे. आता इथं पहा, इन दिस टू ट्रायंगल हियर दीज टू अँगल्स आर कॉन्ग्रुएंट विथ दीज टू करस्पॉन्डिंग अँगल्स. आता जर दिलेल्या दोन ट्रायंगल्समध्ये प्रत्येकी दोन अँगल हे दोन करस्पॉन्डिंग अँगलचे पेअर जर कॉन्ग्रुएंट असतील तर तिसऱ्या अँगलची पेअर ही कॉन्ग्रुएंट असलीच पाहिजे, कारण ते आपल्याला अँगल सम प्रॉपर्टीवरनं प्रूव्ह करता येईल. अँड दॅट्स वाय दिस SAA, this test is nothing but ASA test. ती टेस्ट आपल्याला ASA म्हणूनही लिहिता येते, पण आपण इथं SAA हे दोन अँगल जे आहेत हे दोन अँगलनी ही साईड इन्क्लूड केलेली नसल्यामुळं आपण तिथं SAA टेस्ट असंच लिहितो. तर ही टेस्ट ही ASA टेस्ट सारखीच आहे, त्यामुळं आपल्या सिलेबसमध्ये ही SAA नावाची टेस्ट दिलेली नाही. मग इथं तुम्ही ASA लिहू शकता किंवा SAA टेस्ट लिहू शकता. Here these two triangles are congruent and therefore seg AE congruent seg EC. These are the corresponding sides of congruent triangles, and that is AE equals to C or EC, and hence proved. काय प्रूव्ह केलं आपण? हा मिडपॉइंट थेरमचा कॉन्व्हर्स आहे. मिडपॉइंट थेरम काय सांगतो पुन्हा एकदा सांगतो. द सेगमेंट जॉइनिंग द मिडपॉइंट्स ऑफ एनी टू साइड्स ऑफ अ ट्रायंगल इज पॅरलल टू थर्ड साइड अँड इज हाफ ऑफ इट. त्याचं कॉन्व्हर्स काय आहे सांगतोय, तर या ट्रायंगलच्या एका साइडच्या मिडपॉइंट मधून पास होणारी लाईन दुसऱ्या साइडला पॅरलल असेल तर ती लाईन थर्ड साईडला बायसेक्ट करते. म्हणजेच या ट्रायंगलमध्ये पॉईंट डी मधनं पास होणारी ही लाईन एल जर या बी सीला पॅरल असेल आणि ए सीला पॉईंट ई मध्ये इंटरसेक्ट होत असेल तर लाईन एल सेगमेंट ए सीला किंवा साईड ए सीला पॉईंट ए मध्ये बायसेक्ट करते. हा कॉन्व्हर्स ऑफ मिडपॉइंट थेरम सांगतो. पहा, if a line drawn through the midpoint of a side of a triangle and is parallel to other side, then it bisects the third side. Here in this way we prove this converse of midpoint theorem. Now we are going to solve the solved examples given in our textbook. The first example is points E and F are the midpoints of seg AB and seg AC respectively. If EF equals to 5.6, then find the length of BC. Here, by using the midpoint theorem, we can easily find the length of BC because the segment EF is the segment joining the midpoints of these two sides of triangle ABC, and that's why this segment is parallel to third side and it is half of it. म्हणजे या EF ची लेंथ EC च्या हाफ BC च्या हाफ आहे, म्हणजेच BC ची लेंथ EF च्या ट्वाइस आहे, डबल आहे. हे आपल्याला या ठिकाणी मिडपॉइंट थेरम ट्रायंगलचा मिडपॉइंट थेरम यूज करून सांगता येईल, फाइंड करता येईल. हियर इन ट्रायंगल ABC points E and F are the midpoints of seg AB and seg AC respectively, and therefore EF equals to half BC by midpoint theorem. And therefore here EF equals to 5.6 equals to 1 by 2 into BC, and therefore this BC equals to divide by 2 आहे, इकडे आल्यावर हे साइड चेंज केल्यावर into होईल, and therefore BC equals to 2 6 12 carry 1 2 5 10 plus 1 11.2 सेंटीमीटर. युनिट दिले का? पहा, दिलेला नाही. आपण या ठिकाणी फक्त युनिट असं लिहूया कारण सेंटीमीटर दिलेलं नाही. अतिशय सोपं एक्झाम्पल आहे. मिडपॉइंट थेरमचा यूज करून आपण या थर्ड साइडची लेंथ फाइंड केलेली आहे. Now the second example is prove that the quadrilateral formed by joining the midpoints of sides of a quadrilateral in order is a parallelogram. Here the quadrilateral ABCD is any type of quadrilateral. Point P, S, the point P, Q, R and S are the midpoints of side AB, BC, CD and AD respectively. And we have to prove that this quadrilateral PQRS is a parallelogram. आपल्याला हा quadrilateral PQRS parallelogram आहे हे प्रूव्ह करायचे आहे. म्हणजे या quadrilateral PQRS मधले अपोजिट साइडची एक पेअर जर आपण पॅरलल आणि कॉन्ग्रंट आहेत हे प्रूव्ह करू शकलो तर हा quadrilateral parallelogram होईल, किंवा बोथ पेअर्स पॅरल आहेत हे आपल्याला प्रूव्ह करता आलं तरीही हा पॅरलेलोग्राम होईल. आपण या पॅरलेलोग्रामच्या टेस्ट यूज करून या ठिकाणी हा पॅरलेलोग्राम आहे हे प्रूव्ह करणार आहोत. फर्स्ट राइट द गिवन हियर इन क्वाड्रिलॅटरल ABCD points P, Q, R and S are the midpoints of side AB, BC, CD and AD respectively. Then to prove, what we have to prove here, this quadrilateral PQRS is a parallelogram. Here we construct this segment BD. So here we write the construction. Draw segment BD. Now proof. Here in triangle ABD, point S is the midpoint of seg AD. Point P is the midpoint of seg or side AB. So by midpoint theorem, this SP, seg SP is parallel to side or seg BD, and also seg SP is half to the BD. Similarly, we can show that this QR parallel to BD and QR equals to half BD. आता या दोन्ही सेगमेंट या सेग BD ला पॅरलल आहेत, म्हणजेच PS पॅरलल QR, आणि त्यासोबत या दोन्ही सेगमेंटची लेंथ या सेग BD च्या हाफ आहे, म्हणजेच हे दोन्ही सेगमेंट इक्वल इन लेंथ आहेत, म्हणजेच कॉन्ग्रुएंट आहेत. इट मीन्स दॅट the pair of opposite sides of this quadrilateral PQRS is parallel and congruent. That's why this quadrilateral is a parallelogram. म्हणजे अशा पद्धतीने आपल्याला याचा प्रूफ लिहायचा आहे. पहा, इन ट्रायंगल ABD points P and S are the midpoints of side AB and side AD respectively, and therefore this SP or PS parallel seg BD, and SP equals to half BD by midpoint theorem. Number 1. Now in triangle, see in figure, BCD points Q and R are the midpoints of side BC and CD respectively, and therefore this QR parallel B. Now we are going to solve the examples in practice set 5.5. So the first question is, in figure, point X, Y and Z are the midpoints of side AB, side BC and side AC of triangle ABC respectively. Here AB equals to 5 cm, AC equals to 9 cm and BC equals to 11 cm. Then find the length of XY, YZ and length of XZ. See, in triangle ABC, point X is the midpoint of side AB, Y is the midpoint of side BC and Z is the midpoint of AC. Then by using the midpoint theorem, we can easily find the length of XY, YZ and XZ, because length of all these three sides of this triangle ABC are given. Here in triangle ABC, point X and Y are the midpoints of side AB and BC respectively, and therefore XY equals to is half to the third side, that is equals to half into AC by midpoint theorem. And therefore this XY equals to, here length of AC is given, which equals to 9 cm, half into 9, therefore XY equals to 4.5 cm. Now points Y and Z are the midpoints of side BC, seen figure, and side AC respectively, and therefore this YZ equals to half of AB by midpoint theorem. See in figure, because point Y and Z are the midpoints of side BC and side AC, therefore The segment joining the midpoints of these two sides of triangle is half to the third side. Therefore, YZ equals to half of AB. Length of AB is given, which equals to 5 centimeter, and therefore YZ equals to 2.5 centimeter. Now, points X and Z are the midpoints. हा कुठल्या साइडचे midpoint आहे of sides AB and AC respectively, and therefore XZ equals to half of BC by midpoint theorem. And therefore XZ equals to half into BC given, which equals to 11, and therefore XZ equals to 5.5 centimeter. So in this way we find the length of XY, YZ and XZ by using the midpoint formula in this triangle ABC. Now the next example is example number 2. In figure, quadrilateral PQRS and quadrilateral MNRL are the rectangles. If point M is the midpoint of side PR, then prove that SL equals to LR and LN equals to half SQ. Here, to prove this SL equals to LR, it means that point L is the midpoint of SR. हे आपल्याला इथं prove करायचं आहे. Now in this triangle SRP, point M is the midpoint of seg PR, and if ML is parallel to PS, then by the converse of midpoint theorem, point L is the midpoint of SR. Therefore SL equals to LR हे आपण प्रूव्ह करू शकू. त्यासाठी अगोदर आपल्याला LM पॅरल SP हे प्रूव्ह करावं लागेल. त्याच्यामध्ये here quadrilateral PQRS and quadrilateral LMRN LMNR are the rectangles. Therefore SP parallel RQ, opposite sides of rectangle, and also LM parallel RN, these are the opposite sides of this smaller rectangle. And as this LM parallel RQ and SP parallel RQ, then LM parallel SP. Then by using the converse of midpoint theorem, we can easily prove that point L is the midpoint of side SR, that is SL equals to LR. First we write the given. Here quadrilateral PQRS and quadrilateral MNRL are rectangles. Point M is the midpoint of side PR, and from this we have to prove that SL equals to LR and LN equals to half SQ. Now here we write the proof. See, the quadrilateral PQRS is a rectangle. It is given, and therefore seg SP parallel seg RQ, number 1. These are the opposite sides of a rectangle. Then quadrilateral, the small rectangle is LMNRL is a rectangle. It is also given, and as this is rectangle, therefore seg LM parallel seg RN याला नंबर देऊया 2. आता हे आर क्यू आणि आर एन ही एकच लाईन आहे, त्यामुळं दिस एल एम and line SP both are parallel to segment RP. Therefore, these two segments are parallel to each other, because we know that if two or more lines are parallel to the same line, then these two lines are parallel to each other. Here, from first and second, seg LM parallel seg SP. याला नंबर देऊया 3. Now, in triangle, see in figure, SRP point M is the midpoint of seg PR, and this LM seg LM parallel seg ESP from 3 कारण आपण हे प्रूव्ह केलेलं आहे, and therefore SL equals to LR by the converse of midpoint theorem. आताच आपण शिकलो होता converse of midpoint theorem. काय सांगतो converse of midpoint theorem? A line passing through the midpoint of a side of a triangle and is parallel to another side, then it bisects the third side. ट्रायंगलच्या एका साईडच्या मिडपॉइंट मधून जाणारी लाईन दुसऱ्या साईडला पॅरल असेल तर ती तिसऱ्या साईडला बायसेक्ट करते, म्हणजेच SL इक्वल्स टू SR. आणि हेच आपल्याला प्रूव्ह करायचं होतं, हेन्स प्रूव्ह. हे झालं सब क्वेश्चन फर्स्ट. नाव सेकंड, हिअर LN इक्वल्स टू हाफ SQ हे प्रूव्ह करायचं आहे. आता म्हणजे इथं आपल्याला पॉईंट N हा जर या QR चा मिडपॉइंट आहे हे प्रूव्ह करता आलं तर या ट्रायंगलमध्ये ट्रायंगल SQR मध्ये बाय मिडपॉइंट थिअरम LN इक्वल्स टू हाफ SQ आपल्याला प्रूव्ह करता येईल. आता L तर पॉईंट SR चा मिडपॉइंट आहे हे आपण इथं प्रूव्ह केलेलं आहे. आता फक्त पॉईंट N हा या सेक QR चा मिडपॉइंट आहे हे आपल्याला प्रूव्ह करायचं आहे. सी आता सेम आपल्याला हाच प्रूफ पुन्हा एकदा द्यावा लागेल. नाव क्वाड्रिलॅटरल PQRS is a rectangle. It is given. फक्त पेयर्स अपोजिट साइडचे पेयर्स इथे चेंज होतील म्हणून आपल्याला पुन्हा एकदा हे लिहावं लागते. Therefore, sec SR parallel sec PQ याला नंबर देऊया. पुढचा नंबर जो असेल तो नंबर 4. Then quadrilateral MNRL is a rectangle. It is also given, and therefore sec LR parallel sec MN. Number 4. The segment SR and segment LR, these are on the same line. That's why this sec PQ parallel sec MN, because these two segments are parallel to the same segment. Therefore, these two segments are parallel to each other. Then from 4 and 5, sec PQ parallel sec MN. Number 6. Now, in triangle, see in figure, PQR point M is the midpoint of sec PR, it is given, and sec MN parallel sec or side PQ आपण हे प्रूव्ह केलेला आहे in 6. So here we write from 6. Now in triangle, here this in triangle PQR point M is the midpoint of PR and segment MN parallel sec PQ. Therefore, by the converse of midpoint theorem, point N is the midpoint of side RQ. याला देऊया नंबर 7. रिझन किंवा याच्या अगोदर आपण हे लिहूया. Therefore RN equals to NQ. ह्याला लिहूया by midpoint theorem. Converse of midpoint theorem, sorry, of midpoint theorem, and therefore point N is the midpoint of side RQ. ह्याला number देऊया 7. Now in triangle SQR, point L is the midpoint of side SR from 1. आपण ते 1 मध्ये प्रूव्ह केलेलं आहे. And point N is the midpoint of side RQ. हे आपण 7 मध्ये प्रूव्ह केले. हा वन स्मॉल रोमन 1 आहे, म्हणजे फर्स्ट सब क्वेश्चन मध्ये यातल्या क्वेश्चन सेकंड मधल्या फर्स्ट सब क्वेश्चन मध्ये आपण ते प्रूव्ह केलेलं आहे. And therefore here in this triangle, see in this figure, in triangle SQR, point L is the midpoint of SR and point N is the midpoint of QR. And therefore by midpoint theorem LN equals to half SQ. LN parallel SQ पण आहे, पण आपल्याला ते प्रूव्ह करायचं नाही, त्यामुळे एवढंच प्रूव्ह करायचं आपल्याला की LN equals to half SQ. This is by midpoint theorem. In this way, here we prove that first SL equals to LR and then LN equals to half ESQ.